All right, let's have a look at question number 9. It says in the diagram below, E, C, G, and F are points on the circumference of a circle. EG is a diameter of the circle. The tangent AEB is parallel to CD. Angle AEC is 68 degrees, and angle EFD is 108 degrees. So all that information you can see for yourself. This says determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. So the first angle we need to find is angle ECB. Angle ECD. All right, so the first angle we're asked to find is angle ECD. So that's this angle here. All right, so first of all, it's easy to see that this angle is also 68 degrees, simply because the two angles are alternate angles. So angle ECD is equal to 68 degrees. So it's equal to angle AEC, equal to angle AEC, which is equal to 68 degrees. All right. So below that, it says, what's the reason? So the two angles are alternate angles. The two angles are alternate angles. All right, so let's see what's next. Next, we're asked to find angle CEG. We need to find angle CEG. We need to find this angle here. All right, angle CEG. All right, so for me, looking at it, well, let's go back. First of all, OEA would be 90 degrees. So this entire angle here was 90 degrees. And the reason for that is because the radius OE at the point of contact E is at right angles to the tangent. So to get this angle what I want to find, let's call it theta, I'm simply going to take away 68 from 90 degrees. So this OCE is equal to 90 degrees minus 68 degrees. This would be equal to 22 degrees. And I would say the reason for this is because angle OEA is equal to 90 degrees. And this is because the radius at the point of contact. So the radius, which is at the point of contact E, is at right angles or is perpendicular to the tangent. All right. The next thing we need to find is we need to find angle CGF. All right, so angle CGF, let's change our color here, is this angle here. We need to find that angle, angle CGF. All right, here's how I would do that. I would use the fact that this entire angle here is equal to 160 degrees. Why? Again, they are alternate angles. So it's equal to 106 degrees. So this entire angle is 106 degrees. If that's 160 degrees, I can take away 68 from it to get this angle here. Let's call it alpha. And then alpha plus angle CGF are opposite angles of a cyclic quadrilateral. So the two of them would add up to 180 degrees. So for me, that's one of the quickest ways I think I can arrive at the answer. So I can say angle FEA is equal to 106 degrees. So angle, well, let's not bother with that. This is equal to 180 minus 106 minus 68. All right, let's just get to the answer, then we'll give the reason. This is 100 and 1,800 minus 38. The angle here is 142 degrees. All right, so what's the reason? Angle FEA is equal to 106 degrees. So if I'm given reason, angle FEA is equal to 106 degrees, alternate angles. Next, angle CEF, which is alpha. Angle CEF, which is alpha in our diagram, is equal to 106 minus 68. These are alternate angles. All right. And this was equal to 38 degrees. And now, angle CGF and angle CEF are opposite angles of a cyclic quadrilateral. Which add up to 180 degrees. So angle CGF is equal to 142 degrees. All right, let's look at the B part of the question. In the B part of the question, it says from a harbor H, the bearing of 2 points Q and R are 69 degrees and 151 degrees respectively. Q is 175 kilometers from H, while R is 242 kilometers from H. I says complete the diagram above to show the information. So some of the information was given and some wasn't. So first of all, the distance from H to Q is 175 kilometers. That's a distance. Let's change the color to put in the bearing. Now, bearing is measured clockwise from north. So going clockwise from north. the angle here is 151 degrees. So the angle here is 151 degrees. All right, so that's entire angle indicated by that red, red arc, and it starts from north and come around to the line RH. That entire angle is 151 degrees. Then, so we completed the diagram. Then we're asked to calculate QR, the distance between the two shapes. So let's call this X. So first of all, the angle between the two, this angle here, the angle between the two, let's change back our color. This angle here, between the two lines, let's call it theta. Theta would be equal to 151 degrees minus 69 degrees. So this is 82 degrees. So now I have a non-right angle triangle. I have the length of two sides and the angle between them, and I wish to find the length of the third side. So to find that, I'm going to use cosine rule, which says that a squared is equal to b squared plus c squared minus 2bc cosine a. Now, in the cosine rule, a is the side that is opposite the inclusive angle, which is x. So this is x squared. B and C are the other two sides. So this is 175 squared plus 242 squared minus 2 times 175 times 242, the cosine of the angle between them, which is 82 degrees. All right. So really, all I have to do is put that in my formula and see what it comes out to be. Or I could say that x now would be equal to the square root of 175 squared. I really don't need to work that out. I could just write that entire thing, 175 squared plus 242 squared, 2 times 175 times 242, the cosine of 80 degrees. So if you're skilled enough to put that in the calculator without error, you can just put it in and get your answer. So I put in my square root symbol, open bracket, 175 square plus 242 square minus 2 times 175 times 242 times the cosine of 82 degrees, and then close bracket and press equal. So my answer here is 278.2 kilometer. So so x, which is QR, is 278.2 kilometers. All right. So we're asked to write the answer to the nearest kilometer. So to the nearest kilometer, it's 278 kilometers. All right, so what are we asked to do next? All right, next we're asked to calculate how far due south is R of the arbor H. So how far south can we find R? How far south is R? All right, so what I'll do here is I'm going to continue the north-south line. All right, and then Draw another line here, such that so that this angle here, the two lines I just draw, I want them to intersect theoretically. They intersect at right angles. So this would be the distance east, and this would be the distance south. Let's call it Y. All right, no, south. How far south? So let's call it S. So what we need to do is to find S in order to determine how far south is R from the R by H. Let's find this angle alpha. All right. So let's go red. First of all, alpha would be equal to 180 minus 151. So alpha here would be equal to what? 29 degrees. All right, so alpha here is 29 degrees, where E is opposite, where S is adjacent, and where the 242 is the hypotenuse. So the ratio, the trig ratio that includes adjacent and the hypotenuse is cosine. So let's find that distance S. So I would say that the cosine of 29 degrees is equal to the adjacent side, which is S, over the hypotenuse, which is 242. All right, if I have one fraction is equal to one fraction, I would cross multiply. So S would be equal to 242 times the cosine of 29 degrees. All right, so let's find that distance, put it in our calculator. 242 cosine 29 degrees. And the answer here is 211.7 kilometers. All right, so how far due south is shape R to the arbor? The answer is 211.7 kilometers. In other words, R is 211.7 kilometers south of the arbor.